Alright, it's on.
Hi, Kanaya. Is this video exciting?
You said you wanted something more exciting at the beginning of my videos, so I brought by the most energetic people I could think of.
Watch this video, because this video gonna be lit.
Hi,
Mr. So here we go. We're going to do a limiting reactant problem. And I thought I'd do the last one that's on these excess fund problems over here. So if I can get it back onto my screen. There we go. So we'll do number 3, where we got this 50 milliliters of phosphoric acid and this sodium carbonate. So the way we handle that is, let me get two on the same screen here. We've got an equation written. So we'll have our, that's the wrong equation. All right, so we got this phosphoric acid, H3PO4. Now you're supposed to know that, of course, adic we talked about for acids, so phosphate is phosphoric acid would be phosphate. We're going to add to that sodium carbonate, Na2CO3. That's, of course, a double replacement reaction, so you're going to get sodium phosphate, so Na3PO4. And you also are going to get H2CO3, but you'll remember in the salt lab we did the other day that H2CO3 spontaneously decomposes into water and carbon dioxide. So that's your equation. Now we need to balance that thing, so we've got 3 sodiums and 2 sodiums. You're going to put a 2 here, you're going to put a 3 here. That gives you 3 carbons, so probably going to have to put a 3 over here. Let's see, what about the hydrogens? We've got 2 hydrogens on this side, so probably need a 3 there, and a 2 over here gives us 2 phosphates. We got 2 phosphates. There's your balanced equation. All right, so now we've got 50 milliliters of 2.5 moles per liter. So 50 milliliters is 0.05 liters. And if you multiply that by 2.5 moles per liter, you'll notice, that's a mole, you'll notice that liters cancel. So you got 0.05 times 2.5. Final answer would be 5. I did that incorrectly, I think. So 0.05 times 2.5, 0.125. And that would be moles of phosphoric acid. We've got 1 gram of sodium carbonate, so to change that into moles, it would be 1 gram times, you'd put grams on the bottom, put moles on top. 1 mole is 106 grams. So 1 divided by 106 is 0.0094. And that's moles of sodium carbonate. So now we need to see which one is limiting. So pick one, compare to the other. I'll pick, let's go ahead and pick the phosphoric acid. So 0.125 moles of phosphoric acid. So we know we need put moles of phosphoric acid on the bottom and sodium carbonate on top. So we would need 3 sodium carbonates for every 2 phosphoric acids. So 0.125 multiplied by 3 halves times 3 divided by 2 is 0.1875. Too many sig figs, we'll ignore that for right now. So that's moles of sodium carbonate that you need to consume all of the phosphoric acid. So to consume the H3PO4. All right, then you look back and see how much sodium carbonate do I have. That's how much I have. So do I have enough? Nope. So sodium carbonate is limiting. It's supposed to be a 2 right there. All right, so sodium carbonate is limiting. So 0.0094 moles of sodium carbonate is our limiting reactant. Now if you go up and look at the question at hand, it says our limiting reactant is sodium carbonate. That's what we determined. And our excess reactant is phosphoric acid. Now the next question says what volume of gaseous products form. So the gaseous product would depend on the limiting reactant, and the gaseous product is the carbon dioxide. So we'd take our 0.0094 moles of sodium carbonate. That's interesting. I didn't know my pen has special effects. All right, there we go. That was fine. Now, so 0.0094 moles of sodium carbonate. We're going to multiply by a 3:2 ratio where you're looking for moles of carbon dioxide, because that's the gaseous product. You put moles of sodium carbonate on the bottom. And 1 mole, oh wait, there's 3 moles of sodium carbonate, or carbon dioxide, 3 moles of carbon dioxide for every 3 moles of sodium carbonate. That's going to give us moles of carbon dioxide. We need liters of carbon dioxide because it says what volume. So we come over here. We know that if I put moles of carbon dioxide on the bottom and liters of carbon dioxide on the top, 1 mole is 22.4 liters. So then 0.0094 times 22.4 is 0.21. So our final answer on that equals 0.21 liters of CO2. And that's what it says would be produced if you toggle back over here to the question sheet, 0.21 liters. I gave you the answers. Now, what mass or volume of excess reactant reacts? So we're going to find the volume in this case because the excess reactant was in solution. It's 0.05 liters of 2.5 moles per liter. Okay, to find that, we're going to need to take our limiting reactant again, which is our 0.0094 moles of sodium carbonate, and compare it to the phosphoric acid. So we have moles of sodium carbonate on the bottom. We have moles of phosphoric acid on top. And we know there are 2 for every 3. We know then that 1 liter is 2.5 moles. Okay, let's revisit that. We know that because it says here we got a 2.5 moles per liter solution. And we know that that means then, this little section right here means 1 liter is 2.5 moles. So we take our 0.0094, multiply by 2/3, and by 2, I just multiply by 2, and then divide that by 3, and then divide again by 2.5. So my final answer is 0.0025. So I'll bring this up. So 0.0025 liters. Now, if you change that to milliliters, we all know that there's how many milliliters in a liter? So 1,000 milliliters per liter. So really, you're looking at 2.5 milliliters. So that's how I got that answer. Then the last question says, what volume remains unreacted? Well, we had 50 milliliters to start with. We used 2.5. So this answer just becomes 50 minus 2.5 equals 47.5 milliliters that remained unreacted. So there you have a limiting reactant problem. And okay, I think I'm going to stop it there. Hope that helped. Big picture, find moles of each reactant. Pick one randomly, compare to the other. Find out how much you need to make the first one go away. And after you know how much you need to make the first one go away, you go back and see how much you have. And did we have enough? No. That's how we know that the sodium carbonate was limiting in this problem. Then everything else depends on the limiting reactant. After the reactant goes away, there's no more product, no more reaction. And that's the end of that video.